So,
I've got to get onto my site. My mom's out of the house, so I have to go to the site through my phone and stuff
okay.
because I don't have a computer. Hold on. mymathlab.com.
So are you on GoToMeeting with your phone?
Yeah, yeah.
Okay.
I can still see it fine though. That's the thing.
What's that?
I can still see everything fine.
Okay. It's quite the technology anymore, huh?
I
The
guess so.
You can do two things, like be on GoToMeeting and still log on to that website with your phone.
True.
Who would have
1
thought?
second. Okay, I got the problems right here.
Okay.
I'm just trying to see what lesson that we should start on.
Mhm.
Okay. How about this one right here? Sorry, it's loading and stuff. Takes a while.
All right.
Uh, just a moment. Okay. I think I opened the wrong lesson. Yeah, I did.
Now, are you going to do trig this year also? Is that come in the second semester?
Actually, the reason I'm doing 121 is so I could get the math credit to graduate early.
Oh, that's right. That's right. You're graduating in December. Yeah. Yeah, I forgot.
Yeah, that's why I have to get a
Yeah.
decent grade in math so I can actually graduate.
All right.
Okay. Sorry, everything's taking a while. Alright, you ready?
Uh-huh.
So this one says f of x equals negative x minus 1 and g of x equals x squared minus 3. And we have to find the FOG and negative 2.
X squared minus 3?
Yeah, x squared minus 3.
Okay. So, and here's what they want. They want f of g of negative 2.
Let me just double check. Yeah.
Okay. First of all, let's talk about this terminology. Why do we use f of x instead of y? It's because it allows us to substitute a number in there. What would f of 3 be?
Would you just substitute 3 where the x is?
Whatever is in the parentheses is what you substitute wherever x is. So it'd be minus 3 minus 1 equals minus 4. Okay? And
Okay.
now, what if we said, let's do f of x squared? What would that be?
You would just substitute x squared in for the x. Or square whatever's in the x thing, yeah.
Yeah, in other words, just for clarification, you might put parentheses around it. So when they talk about composite functions, in other words, when they say what is f of g of x, then whatever g of x is we're going to substitute it inside the parentheses. So that's the same as saying f of x squared minus 3. That
So
is
that's
the
what g of x is.
composite function. And now,
Okay.
wherever we encounter x, we substitute x squared minus 3. So it would be minus, in parentheses, x squared minus 3. I would say always get in a habit of using parentheses because they're needed 95% of the time. And there is the answer, okay?
Okay, so f of
They, instead of asking the general composite, what is this, f of g of x, they've actually put a number in for x to make it a little more specific. Well, let's go and figure out what g of minus 2 is. In other words, this is actually a little easier than what they could have done. What is g of minus 2?
G of minus 2?
Uh-huh.
Would you plug it into the f of x, right? Or
Well, not the f of x, the g of x. What's the g of x function?
it's x squared minus 3.
So what are we going to plug in and where?
We're going to plug in negative 2 where the x squared should be.
And include the parentheses because it matters here.
Okay.
That turns into a positive 4. So g of minus 2 is 1. So what they're really asking for is f of 1.
F of 1?
Yeah, and then we go back to the f function. What do you get? What is f of 1?
It would just be negative 2, wouldn't it?
Uh-huh. And that's how you do it. And like I said, this is very specific where you figure out what g of minus 2 is first. But if they wanted the general answer of what f of g of x is, well, that's it. That covers all scenarios. I could actually take this formula here and substitute minus 2 for x and get my correct answer. You'll notice that I get minus 2 if I do that.
Sounds good.
All right, what else you got?
Are we ready for the next? So the next one is f of x equals 4x plus 2. And g of x equals x squared minus 3x minus 6.
Did I get both of those right?
Well, let me look. I'm just reading it off. Yeah, that's right. Then we have to find the GOF of 6.
You have to find G, O, F evaluated at 6. GOF. What that also means is this. G of F of 6. Those two things are the same expression. In other words, they got lots of terminology for meaning the same thing. GOF.
So would you plug in the whole F equation for the F and the G?
I would, when they give you a specific again, it's much harder to figure out what G of F of X is. That's a lot of math. So the easiest way to do this problem is always work from the inside out. Figure out what F of 6 is. What is F of 6? In other words, once we convert everything to numbers, then it'll be an easier problem.
Okay. That makes sense.
What is
so
that?
Then you'd have 4 times 6 plus 2.
It's 26. So what they're really saying is what is G of 26? Now, plug that into the G function.
Okay, so we'd get 26 parentheses squared minus 3 times 20, or parentheses 26, minus 6.
Okay, and whatever that number is the answer. If you need an answer, if you're plugging it in as we're going along, go ahead and use your calculator and come up with a number there. If you're not doing that, then we can go to the next problem. Now,
plugging it in.
This is arithmetic. I'm assuming you know how to do this on your calculator.
Yeah, I do.
So I would suggest we not spend time doing arithmetic, that we do the harder.
Okay.
Okay? What else?
Where can I, oh, by the way, where can I find the lessons online that we've done together?
If you go to YouTube /digital math tutor.
Okay.
Here, I'll show it to you real quick. First of all, if I go to YouTube, for me, I actually have a thing there, but it's my digital math tutor. It's called this. Here, let me put this. I'm going to copy and paste this into GoToMeeting, the chat window. You know where the chat window is?
Yeah, I do.
Click on that link and save it.
All right. I'm gonna copy it.
And actually, if you just click on it, it'll pop open in your browser automatically, and then you can hit
Yeah, I have it saved.
the save button, and you'll always be able to get back to it. Now, your file has your initials and the date. Like this person was Jake Z for October 5th, 2017.
All right, that makes sense.
Cole W, yours are going to be MW for Merrick Weaver, and then whatever the 6 digits are for the month, day, and year. The last 2 digits of the year. Okay? And click on any of these and you can play it. Okay?
Alrighty.
All right, let me close that out. Let's get back to these. Hold on.
All right, let me go get the next equation real quick.
Yeah, do that while I'm getting this thing reloaded back up. All right, I'm ready.
I'm skipping.
Unfortunately, I do have a 6 o'clock today that I have to go to, so I don't have much flexibility, but
that's all right. I wasn't expecting that much. Oops, all right. So we have to find, this one says find f of x and g of x such that h of x and f of g of x. And the equation is h of x equals 2x plus 5 parentheses squared. The whole thing is parentheses, yeah. Did you get the equation there?
H of x is equal to what? F of g of x?
F of g of x, yeah.
So fog of x, which is the same as f of g of x. So you have Goff and you have fog. Now, the one thing to understand, the reason we're talking about all of this is that they are composite functions. Okay? In other words, they're not a straight function, they're actually a composite of 2 different functions. In this case, one of the functions is 2x plus 5, and the other function is x squared. Okay? So let's play around with a little bit of combinations here. Let's see, if I'm looking at fog, then I want that to be x squared, and I want that to be 2x plus 5. Now, notice what fog would be. In other words, if I complete this, it would be f of 2x plus 5, right? That's what I'm saying g of x is. And if I did f of 2x plus 5, this is what I'm going to get. I'm going to substitute 2x plus 5 in for x, and I'm going to get 2x plus 5 in parentheses, all squared. Okay. Now, the reason this is hard is because they're making you go in reverse. In other words, we've only been going forward for 20 minutes here. And by that, I mean figuring out what composite functions are. What is f of g of x? What is g of f of x? All of those kind of questions. Here, they're giving you the composite function and they want you to go backwards. Well, it's pretty easy for me to see that this is something squared. So I figure one of the equations is x squared and the other one is 2x plus 5. And that's all I have to do is figure out which is which. Well, clearly this combination works. In other words, if I plug that in to there, I get h of x. I get 2x plus 5 squared. You see that?
I do.
Okay. It's definitely harder going backwards than it is forwards. So you kind of have to experiment a little bit sometimes with it. What else did they give you? We should have, yeah, we got lots of time. What else they got on the order of this? It's worth doing a few of them.
H of x.
Well, where they want to know what the original functions were, and they give you the composite function. Those are the hard ones.
No, they don't have any of those yet.
Okay,
that was like
well,
the
we just
last
did one.
problem.
That one we just did was exactly that. They gave us the composite function, and they wanted to know what the f of x function was and what the g of x function was. In other words, a composite function is always made up of two or more functions. So if they give you a composite function that's made up of two functions, they want you to figure out which two functions. Those are the hard, like I said. But whatever you got next, we can work on.
Okay, let me look. So the next one is f of x equals 6x plus 1, and then gx equals the square root of x. It says find the FOG of x and the FOG and the GOF of x in the domain of each.
Okay. So let's find f of g of x first. So how can I rewrite that?
You can plug in the f of x equation in the g of x.
Around. Always go from the inside out.
Oh, yeah. So
that's the same as f of what?
F of g of 6x plus 1, right, or no?
Here's the g of x function right there.
Oh, yeah.
Whatever that is, that's what you plug in. So it's
square root of x.
Now, plug that in to that function. So what do you get?
Okay. So we get f of x, or f of the square root of x equals 6 times the square root of x parentheses plus 1.
Yeah, I don't need the parentheses here because it's all, in other words, parentheses might be for clarification, but they're certainly not needed. So that is f of g of x. Now let's figure out what g of f of x is. Rewrite this for me. Excuse me, g of f of x.
G of f of x.
So what goes into parentheses?
We have 6 square root of x plus 1.
We're starting all over again.
Oh, okay.
That's f of x.
Drop my headset. So, would we put the x squared in then?
This answer is not based on the previous answer.
Okay.
We're back to square one. Whatever f of x is, fill it in the parentheses. What's f of x?
Is it f of the square root of x?
No. Here's f of x right there. What is it?
It's just 6x plus 1.
Okay, that's what goes in there.
Okay.
See why? In other words, that's f of x. Now, tell me how to solve for g of 6x plus 1. Go to the g function. Substitute whatever's in the parentheses wherever you see x in the g function.
Okay, so it'd be the square root of 6x plus 1.
That's it. Here's your answer. That is g of f of x. Okay? And notice that these are going to be a little harder because they didn't give us a number. When they gave us a number, we could figure out what the inside the parentheses was and then plug it into the f function. Well, this, you have to plug the function in, which is definitely harder conceptually. Now, they want to know domain or domain and range or just domain?
They said just domain.
All right. Let's talk about each function first. What's the domain on f of x?
See, I don't know how to find domain of these equations at all.
Let me tell you what domain is. Domain is...
I understand the domain and range, but
well,
I don't know how to find it on these.
Here's the way. You try to figure out what it can't be. You don't figure out what it can be. You figure out what can it not be. Is there anything that x cannot be in the f of x function?
In the f of x function.
Uh-huh. 6x, that's 6x plus 1. Are there any values of x that create problems?
Any values of x? Could it be negative?
Sure.
That wouldn't work?
No, that works. You can plug in a negative number for x. You can plug in 0 for x. You can plug in a fraction. You can plug in a billion. You can plug in minus a billion. So all reals are the domain in the f of x function.
All real numbers are the domain?
That's the domain of f of x. Now let's look at g of x. What can we not have for x in this?
Real numbers?
We have to have 0 or positive numbers. So the domain for the g of x is greater than or equal to 0. That's the domain for the g of x function. You cannot take the square root of a negative number. You can take the square root of 0. So 0 is in the domain. But that's how you want to think about domain. It's not so much what it can be, is what can it not be. If I give you a function 1 over x, well, that can be anything in the world except 0. X cannot be 0. You cannot divide by 0. You can divide by any other number you can think of, but you can't divide by 0. So that's how typically you want to think of domain, is what can it not be. Because an awful lot of functions, domain is all real numbers. Just like this linear function f of x. There's no restrictions on x. It can be all real numbers. Now, they're going to ask about what is the domain of the composite function. Well, our first composite function, which is that one, that's f of g of x, right?
Yeah.
What's the domain on that?
Well, because if it's square root, right, it can be 0. So is it real numbers as well?
Domain is the g of x. In other words, x has to be greater than or equal to 0. And what usually happens here is whatever the most restrictive domain is, that's going to be the domain in the composite function. Although, notice what g of f of x is. The square root of 6x plus 1. Well, that's going to present a different domain. What's the domain of the square root of 6x plus 1?
6x plus 1. And it's the square root?
Yeah, which
Well, then it
means
has to be greater than 0,
6x
right?
plus 1 has to be greater than or equal to 0. In other words, whatever's under that radical sign has to be greater than or equal to 0. Okay, now let's solve that inequality. That means x has to be greater than or equal to minus 1/6. Well, that's a different domain. That's a new restriction. So on the g of f function, our domain is different than it was on either the f of x or the g of x function. They each had their own domains. And our second composite function had a different domain completely. It merely has to be greater than or equal to minus 1/6. Now, here's the thing. The original domains rule.
The original domain's rule.
Rule.
What does that mean?
Well, that means this second domain that I came up with that says x has to be greater than or equal to minus 1/6, that's really not the answer. In other words, the answer is back there. X has to be greater than or equal to 0. It can't be minus 1/12. It can't be minus 1/20. That would violate the domain of g of x. So when I say that we calculated it to be greater than or equal to negative 1/6, but the reality is that the original restriction on the domain holds. Has to be greater than 0, which is not the same as greater than or equal to negative 1/6. This has some possibilities that would not work for the g of x function.
Okay, that makes sense.
Well, the lesson here, this is a hard one to learn. The lesson here is that the domains of your original functions, not the composite functions, but the domain of your original functions always take priority. And since the domain of the g of x function was greater than or equal to 0, even when we calculated the composite function where it had to be greater than or equal to negative 1/6, no, it can't be equal to negative 1/6. That's going to violate the original g of x function. In other words, it's still got to be greater than or equal to 0.
Okay, I got it.
Okay? That's one of the finer points about composite functions and domains.
Alrighty.
That the more restrictive domain carries forth.
The more restrictive domain carries forth.
Restrictive domain. In other words, x being greater than or equal to 0 is a little more restrictive than x being greater than or equal to negative 1/6, right? There's less numbers on the number line when it has to be greater than or equal to 0. So it is the more restrictive domain. So you have to use it, not the domain you calculated from the composite function. If I was dealing only with the composite function, then that tells me that x merely has to be greater than or equal to negative 1/6. But by definition, you got to go back to the domain of the composite function, or of the individual functions.
Okay.
Merrick, I'm going to let you go so I can get to my next session. But
Thank you, appreciate it.
Talk to you next time.
I see you.
All right, bye-bye.